Okay, in this video we're going to do a little introduction to trigonometry. Okay, we're not going to go into the nitty-gritty nuts and bolts of equations and formulas and things like that. We're just going to look at what is trigonometry and why we're interested in it. Okay, so trigonometry comes from two Greek words which mean triangle and measurement. Okay, so it's obviously about the measurement of triangles. Now, what can you measure in a triangle? Well, there's three things that are most obviously able to be measured in a triangle. One is the side lengths. The other one is the angles. Another one is the angles. And the last one is the area of the triangle. And it turns out that there are interesting relationships between these three quantities for any given triangle. Its area, the side lengths, and its angles. They're all linked together for any particular triangle that you care to look at. So in this video we're not going to look at what those functions and formulas are, how to find those relationships. We'll do that in later videos. But in this video we're just going to look at what is it about triangles and trigonometry that makes them so interesting and so worthwhile to study. That's what we're going to look at. So one good question to ask is, why triangles? What is it about this shape that makes it worth spending an entire unit on? Why aren't we doing a unit on squares or pentagons or any of the other, hundreds of thousands of shapes that we could look at? What's so special about triangles? And in particular, right angle triangles. Okay, well, one way to think about it is a triangle is the most fundamental shape that you can get. The most fundamental two-dimensional shape that you can get. A square can actually be made up of triangles. You can look at a square and say, well, that's just four triangles arranged in a certain way. You can say the same thing about a pentagon, actually. It's just made up of lots of triangles, and each of these triangles, if I'd drawn the pentagon perfectly, would have the same size, area, angles, everything. It turns out that that's true for every regular shape. Every regular polygon, which just means every shape that has the same side lengths and same angles in it, can be made up of triangles. Let me show you. So here's a progression of regular polygons, so shapes of increasing numbers of sides, but in every case having the same side lengths. Each shape in itself has the same side lengths and the same angles, and you can see that each of those shapes can be considered to be made up of a series of similar triangles, all with the same size, the same side lengths and the same angles. And it's pretty easy to see that if you continued this pattern on to the next number of sides, which would be a nonagon and then a decagon and so on, that you'd be able to keep doing this. You'd just be having smaller and smaller triangles and more of them in each shape. So you could go on doing this forever. You could make any shape out of a series of triangles. But that's obviously not true about other shapes. You couldn't make a triangle out of pentagons, and you couldn't make a hexagon out of pentagons. You couldn't do that for any other shape except a triangle. It seems to be the most fundamental one. There's something special about it. Now, you may have noticed that as these regular polygons are increasing in the number of sides they have, they're starting to get rounder and rounder. Okay, let's imagine what would happen if you had a shape that had 100 sides. It would start to look very much like a circle. Well, we can see that. I'll show you. Here's a chart that shows lots and lots of different shapes, regular polygons with increasing number of sides. So we've already seen these ones that have 4, 5, 6, 7, 8 sides. These ones have 12, 13, 14, 15, 16, 17 sides, 18 sides. When you get up to 100, it's pretty hard to tell how that isn't a circle. It looks very, very much like a circle from this point of view. If you got really close, you might be able to see the sides, the little tiny sides that it has, but looked at from a distance, it looks almost exactly like a circle. Well, since we know that all these other sides, that they can actually be composed of or broken down into triangles, then that would have to be true of this 100-sided shape as well. It would have to have 100 really, really thin slices which are triangular in shape, just like the hexagon does. Just like every other shape could be made up of triangles. So if we kept increasing this number of sides from 100, let's say we got up to 1,000,000 or 1,000,000,000, it would be impossible to tell it apart from a circle. Even as you got really close, it would be hard to tell. And if you imagine it had an infinite number of sides, well, it would be a circle. That's what a circle is. And so not only can you make regular polygons from triangles, which is very obvious, but also a circle which has round sides. That's pretty amazing. Because of the fact that triangles are so fundamental and that they can make up every other shape, this means that they are everywhere. Let me show you. Here's just a few of the ways, or a few of the examples of triangles in everyday life. Some of these things you can see around you if you go outside. Other things, you'd have to go all around the world to see. But the key point is that triangles are everywhere if you look for them. So not only are triangles everywhere, but in fact you can create triangles out of just about any situation. Just to take one example. Say you're standing next to a building and you're looking up at the top of the building here. Let's draw a line from our eyes up to the top of that building. Okay, we can actually say that this line, this distance from your eyes up to the top of the building, it's composed of the straight bit that goes towards the building, the bit going horizontally, and also the vertical bit that goes up the building. Okay, we can say that this line is kind of made up of these two bits, the bit going across and the bit going up. And if you remember your Pythagoras' theorem, that fact can be expressed using the equation c squared equals a squared plus b squared. In other words, the long hypotenuse, the longest side of the triangle, the square of that side, is equal to the square of the horizontal side plus the square of the vertical side. Okay, so the long side is made up of the short side and the vertical side if they're each squared individually. Now that's going to be true for any situation where we have a line. Anytime we have a line, we can say, well, that line, let's consider that it's made up of a horizontal bit and a vertical bit. This simple fact, this simple little situation has almost an infinite number of implications. There's almost there's no limit to how many different situations that is useful in. Here's a few examples. So here's a list that I just grabbed off a Wikipedia article, and it lists all the different fields of study where trigonometry and this understanding about triangles will come in handy. From obvious ones like cartography, so if you're drawing a map and you're trying to chart the distance from one place to another, to civil engineering, if you're making a building and you want to know how long your support beam needs to be or how strong it needs to be, electronics if you're drawing circuits, physical sciences if you're doing physics, astronomy if you're trying to work out distances between stars and galaxies and things like that, oceanography, earthquakes, statistics. There really just isn't a limit to how many different uses you can find for trigonometry. I thought I'd finish by just showing you this quote by a man named Thomas Paine. He lived maybe 200 or so years ago. He said this: "The scientific principles that man employs to obtain the foreknowledge of an eclipse or of anything else relating to the motion of the heavenly bodies are contained chiefly in that part of science that is called trigonometry, or the properties of a triangle, which, when applied to the study of the heavenly bodies, is called astronomy. When applied to direct the course of a ship on the ocean, it's called navigation. When applied to the construction of figures drawn by a rule and compass, it's called geometry. When applied to the construction of plans of edifices, it is called architecture. When applied to the measurement of any portion of the surface of the earth, it is called land surveying. In fine, it is the soul of science. It is an eternal truth. It contains the mathematical demonstration of which man speaks, and the extent of its uses are unknown." So if that doesn't show you why trigonometry is worth studying, then I guess nothing will. It's possibly one of the most useful things that you can learn in mathematics.